Welcome to the video lesson for section 6, 6.5. I told you in class that in between sections 6.6 and 6.7, we were going to do a quick review over some algebraic ideas having to do with slope, slope-intercept form, lines in the coordinate plane. Just because in section 6.7, we're going to have to start working with these things, and we haven't seen it in a while. So the first thing we're going to do is recall the slope formula. Y sub 2 minus y sub 1 over x2 minus x1 is the formula that we use when we're actually given values or coordinates for points. But if we're looking at a graph, we can either pick a couple points and find the coordinates, plugging them into this formula, or we can simply count our rise over run. The example that I'm going to show you is actually doing the algebra, the math, with a couple of values. So I'm going to begin by writing down my formula. Slope equals y2 minus y1 over x2 minus x1. Now for my points, I have x and y values. So I just need to take my y values and subtract them, and my x values and subtract them. So negative 2 minus 7 over 5 minus 3 gets me negative 9 over 2. So my slope is negative 9/2. So then there's a you-try problem for you to go ahead and try. Please put that in your notes and show it to me in class. The next thing we're going to discuss are the different types of slopes. You should probably remember this from algebra last year, but we have 4 pictures here. The first picture is of a positive slope. It starts low on the bottom left corner, then goes up, just like you would go if you're climbing a hill. Then we have our second picture, which is a negative slope. So this is like if you're running down a hill. Our third picture is a 0 slope, because there's no slope to this whatsoever. And then the last example we call undefined. It's like it's so sloped that we don't even know what to call it. It's like a straight up and down, undefined slope. So now we also need to remember what a couple of the different ways we can write an equation of a line is. So we've got slope-intercept form, which is y equals mx plus b. This tends to be the form that most people remember. But we also have point-slope form, which is y minus y1 equals mx minus x1. Now it's important to remember that m is your slope and b is your y-intercept. Again, in point slope, m still represents your slope, but now you've got y1 and x1, those are your coordinates values. So if they give you a coordinate, I would plug those values in where I see x1 and y1. So I'm going to do an example here. It asks me to write an equation of the line containing a slope of negative 2 and the point 5, 7. Now I have 2 different forms, either slope-intercept or point-slope. In this example, I was given slope and a point. This point is not my intercept, so I'm going to use point-slope form. So let me rewrite that down here. Y minus y1 equals mx minus x1. And then I'm going to plug in y minus my y1 value is my y value of my coordinate. So y minus 7 equals m is negative 2, x minus my x1 is 5. This is the answer in point-slope form. Now, if they said specifically, we need you to answer this in slope-intercept form, then you could easily do that simply by distributing your negative 2. So y minus 7 equals negative 2x plus 10. and then moving your 7 over to the other side. This gives you y equals negative 2x plus 17. So now that is your answer in slope-intercept form if you needed to provide them with that. So we can always plug in to point-slope form and then just distribute and move the thing away from the y in order to get it into slope-intercept form. So you go ahead and do your U-try, show that to me in class. And the next thing we're going to talk about are parallel and perpendicular lines. So we have mentioned this in class, and hopefully you remember this from last year, but parallel lines will always have the same slope, no matter what they are. So if one line has a slope of 3, then the parallel line would also have a slope of 3. But perpendicular lines have opposite reciprocal slopes. Well, what is an opposite reciprocal? Let me give you some examples. Let's see. If I told you that the slope of one line was 1/4, well, then the slope of the other line is negative 4/1. So what I've done is I have switched my sign. So my first one was positive, my second one must be negative, and I flipped my fraction. So let's look at another example. If I originally told you negative 2/3 was the slope of one line, the slope of the opposite reciprocal, or the perpendicular line, would be positive 3/2. So I switched from negative to positive, and I flipped my numbers over the fraction bar. So my first example here is I need to figure out what the slope of a line parallel to y equals 4x plus 3 would be. Well, I just need to figure out what the slope of this line is. And if I think about slope-intercept form, I know that m is 4. So my slope is 4. And if I want a slope of a line parallel to that, then I want a slope of 4. Again, you try the next problem. Show that to me in class. So here we're going to look at how to check for parallel or perpendicular lines. And I told you on the first slide that if we want to check the slope of a line, if they give us 2 points, we can plug those 2 points into our formula. But here, they've actually given us these pictures. So what I can do is I can count my rise over run. So I'm going to get black here. I'm going to count from one point, this point here in this example, up to this point. I'm going to count my rise over my run. And then for the second line, I'm going to do the same thing, rise over run. So let's go ahead and do that. I need to go up 1, 2, 3, 4, 5, 6, 7, 8. So up 8, that's my rise. My run is going to be over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 is my run. So my slope is 8/12. But we can reduce that. We can divide both of those by 4. So my simplified slope is 2/3. So now I need to use a different color to check my other line. I'm going to start at this point down here. I'm going to move to this point up here. I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my slope is the same. It's 8/12, which means, yes, my lines are parallel. Okay, so now I'm going to check this second problem here. It looks like my lines are probably perpendicular. They're definitely not parallel because they intersect. But in order to determine whether they're perpendicular, I have to find each of the slopes and see if they actually are the opposite reciprocals. So I'm going to do the same thing I did in the last problem, except here I'm going to go from this point to this point first. So up 1, 2, 3, 4, 5, 6, 7, 8. Up 8. And then run. Ooh, I'm going left, so that's negative. -1, -2, -3, -4, -5. Run, -5. So that means my slope is -8/5, which does not reduce. Okay, so now I'm going to pick a different color, and I'm going to start at this point here and go to this point here. So up 1, 2, 3, 4, 5. Rise is 5 over 1, 2, 3, 4, 5, 6, 7, 8. My run is 8. So here my slope is 5/8. And the last thing I need to do is I need to compare those two values. So is -8/5 the opposite reciprocal of 5/8? Yes, it is, which means that my lines are perpendicular lines. The last thing that we're going to do is we're going to combine our knowledge of parallel and perpendicular with our knowledge of writing the equation of a line. Okay, so here, my first example. What is the equation of a line parallel, ooh, that's important, parallel, to y equals -3x plus 4 through the point -2, 1? So what they've done is they've given me a slope, because if I want a line parallel to this slope, then I want my slope to be -3. And they've given me a point. So what I can do is I can plug into point slope form, which remember was y minus y1 equals mx minus x1. So I'm going to plug in my slope and my point that they've given me into this formula. Y minus 1 equals -3 x. Oh, if I'm subtracting a -2, I should really just put a plus. That's my answer. They didn't ask me to write it in a specific form, so I can just give them that answer, which is written in point slope form. And then there's that one last U-try for you to do. And then other than that, I will see you in class. Make sure that you have these notes ready for me to check.